Okay, so welcome from my side as well. I will show you our software for flood protection design, AQUATERRA. And let's start with this. So this is a part of Ljubljana. It's a capital city of Slovenia. This is in the year 2014. And as you can see, serious flooding has occurred due to heavy rainfall. On the other hand, in 2023, which was also a year where we had big floods in Slovenia. In that time, this area experienced similar rainfall amount, yet it wasn't flooded. And the reason was that the Slovenian company ZVOR designed the plan for flood protection of the Gradaščica River basin, which runs through this part of Ljubljana. This project was funded by European Union Cohesion Fund, and company ZVOR prepared the project documentation for the construction of flood control facilities that were implemented in time, meaning before 2023, and this area wasn't flooded because of that. AQUATERRA played an important role in this matter since it was used to design the river geometry, and then MIKE software was used for the hydraulic analysis. Companies ZVOR shared their project documentation with us. So here are a few samples of layout and cross sections. And if you scan this QR code, you can learn more about this success story and also find other customer stories in our website as well. So yeah, AQUATERRA is primarily used for river and channel design, flood protection design, torrents and landslide control, and river restoration. However, it can also be used for open channel irrigation systems and also earthworks. So you're able to calculate the quantities like materials in cut and fill and do this section by section. And you can also create the summary table as you can see in the picture. So now I will show you the basic workflow in AQUATERRA and how to design flood protection measures with it. Let me just say, if you're just starting with AQUATERRA and you need a detailed step-by-step workflow to learn the basics, you can watch our online AQUATERRA training course, which is free and available if you just scan this QR code. But today we will go a bit faster through these steps. We will first create the river model in AQUATERRA. Then we will export this model to HEC-RAS. You can also do it with MIKE, but today we will only show it in HEC-RAS. We will perform hydraulic analysis there. Then we will design a new river channel in AQUATERRA according to the hydraulic analysis. We will define a new river bed, design new terrain in cross sections and add a dike. And then we'll export this designed model to HEC-RAS again and do the hydraulic analysis again and import the results back to AQUATERRA. So this is the plan, and let's start with this first step. Let's create the river model in AQUATERRA. So here I have some river alignment that I drew with the polyline. And with AQUATERRA, you can just use a polyline to alignment tool, and you can create a longitudinal alignment. So now this alignment corresponds to the river alignment in the alignment manager because I selected it. Then next step would be to create some sample lines like this, and you can change the starting and ending station, and then you can define the width of the cross axis and the distance between them. And let's just change the scale of these labels to get a better view. Okay, and now we have this alignment and the sample lines. And we will create, those are actually placed on elevation 0, and we want to drape them to the surface, but first we need to create it. Here we have some 3D points and 3D polylines, which are a result of geodetic and bathymetric survey. And from this, we can create terrain. We will also add some LIDAR points just to get bigger area covered. So like this. And I will just hide those attributes. Okay, so these are the points which we can use now to create the DTM terrain. And you just select all the data that you want to use for creation of DTM, and then you can represent it with triangles or contours. So now we have created this terrain, but I will just hide the triangle so the model will work a bit faster. Now we have created the DTM with AQUATERRA, but you can also use BricsCAD or civil surface as well with AQUATERRA. Okay, so let's go to the top view, and now we can drape the lines, so sample lines and longitudinal line to the surface. What happened now, those zero elevation lines came up to the surface, and now we have them here. So now we can draw the profile view, and we will get the elevation of the riverbed here in profile view, and we can also add cross sections. Like this. So now we have geometry of cross sections, and we also have the alignment, and we can export this using our function export to HEC-RAS to HEC-RAS. So if you look now, we go to the second step. We will export the model to HEC-RAS and do the hydraulic analysis there. Just to show you how you import the AQUATERRA geometry, you just go to File, Import Geometry Data, and select HEC-RAS format. And then this G00 file will get exported from AQUATERRA, and you can then check if everything is all right and finish to import data. And now you can see cross sections and the alignment in HEC-RAS. Then you need to set the model, which I have already done in a different project. So the model looks like this. Let's see it in 3D view. We have added a surface made from LIDAR data, and also we added some buildings into this model. And now if I play this, and we also did some hydrological analysis, we added, of course, the input data for this. And now if I play the animation, here you can see what happens. This river floods the residential area. So what we want to do now is to go back to AQUATERRA and design a new channel. So design a new riverbed in profile view, and then also design new terrain in cross sections. And we will also add a dike. I will show you how to do it in a moment. So now here we can add a deeper riverbed with a draw profile view. You can just draw it, or I have saved this profile of this new riverbed, and I will just add it here. So this is our new deeper riverbed, and we can add it to cross sections with this insert profile option. So now we get this point, which is an elevation of this line actually in cross sections, and we can draw some cross-section elements. And in AQUATERRA, you can use cross-section elements that are typical for river regulation. And for example, you can add channel or dike or embankments. So if I just show you how to do it, you have all the parameters here. You just set them. You can see in the picture which parameter you are setting, and then you can also select on which cross sections you want to add this typical cross-section element, and then you click OK, and you will see that this element gets drawn on all the cross sections that I have selected. And I can also add a dike, for example, here, and it also gets drawn on all the cross sections. Except from when this is lower than the terrain, because here we want to actually draw embankments. We want to draw them in cut, so I will do like this. And this is how you can add elements on all the cross sections, which makes your process faster. You can also edit these elements if you select it, and then you can here you can change the slope of this embankment, so it changes. And because I have selected only this cross section, it will change only in one, but I can also select more. Then you can also save this typical cross section, this regulation that we just did. You can save it. We save it as a macro, and then you can also play. Actually, you can load this macro, and I have pre-saved a macro here. So I will show you how this is done. I want this to be put on all cross sections. So I select this one, and then this regulation that I already pre-prepared is done on all the cross sections. Okay, and now what we have to do is to assemble a new terrain line, because we want to export this new terrain to HEC-RAS. You just select all the elements that you want to include. So we want to include channel, left and right dikes, left and right embankments, and I will name this new terrain. And now this new terrain is created on all the cross sections, as you can see. So another thing that we want to do, so we have now made this riverbed deeper, and also we have changed the profile of cross sections to be a bit wider. And now we want to also add a dike on this line here. And to do this, I only have to add a new axis, and I will name it dike. And then I will do actually everything I did for the channel, but I already have prepared this so we don't lose time. So what I did is actually I just have made cross sections. I mean sample lines. I draped everything to the surface, and then I made a profile view with this line representing the crest of the dike, and this is this point here. So this will be the crest of the dike, and I will also draw. Wait just a second. Yeah. So I will draw. Okay. So I will draw the dike here. I will use this TCS dike. Again, I prepared this macro in advance, so I can now just I can now just run it here. Okay, so now we have a dike here, and actually we have everything we need to go back to HEC-RAS, but there is just one more step I want to do. So I want to show you how to put this dike in HEC-RAS so it becomes part of the terrain. So to do this, we will create again the new terrain line. We will select this dike, all the elements, and this will be named and now, because I only want to include this part of the terrain, I will use trim command. This trimming command only works on the cross sections of AQUATERRA, but when you use it, it will work on all the cross sections. So you only need to do this on one, like this. Okay, so we only have this part now, and as you can see, it's on all the cross sections. And I want to now export only this terrain, this part of the terrain. I will do it again with HEC-RAS export to HEC-RAS. And let's see where we are now. So we have added all these things, and now we will export the designed model to HEC-RAS. So just to show you first how you create a terrain, including the dike. So you would import the dike using import geometry data HEC-RAS format, as we did before for AQUATERRA, and you will get the alignment with cross sections of the dike. And then you will go to RAS mapper, where it is possible to use export layer. So to export this geometry, these cross sections and alignment to GeoTIFF. And then when you have, you save it as dike, and then you can add a new terrain. You can create new HEC-RAS terrain. You select plus button and you just select dike, and you will get something like this. But then if you want to join this to your existing terrain, you just go here, you create a new terrain, you select plus button, you add dike, and you add your existing terrain, which is in our case some leader data. You make sure that dike is above the your basic terrain, and then create. You click create, and you will get something like this. So a terrain which also includes the dike terrain. So this is how you import the dike into HEC-RAS. And now, now let's see the designed state of HEC-RAS analysis. So I have it here. And now, if you look what we did, we made this channel wider. We also made it deeper, and we added this dike here. So now let's see what happens with the water, if it also floods the residential area or not. And as you can imagine, I have set everything so we made this regulation in a good way so it doesn't flood the residential area. Okay, so now we go to the last step, which is we will import the results of hydraulic analysis back to AQUATERRA. So let's see the AQUATERRA. If you go here, Okay, we can go to utility and use HEC-RAS import from HEC-RAS, and we will then have an option to add water surface levels. You just have to select the right alignment. Okay, so now the water surface level is imported, and you can also add it to the profile view. Surface levels. Okay, so now we also have it here. So this is how you can import the results back. And now let's see another thing. We can also create a planimetry here and quantity takeoff analysis. So I will use a material and then define the polygon which I want to do the planimeter on. This one and this one. So again, you have to select the right alignment. Okay. And now we get the polygon here, and we can make a quantity takeoff. So we insert in the drawing the places of where I want those information to be imported. And now we have here the information of the fill material, quantity, and also I have a quantity takeoff table with all the quantities inside and also the summation of all the quantities. So when you have this planimetry, it is very easy to create a 3D model with AQUATERRA. So I will show you in the example of this dike. Or maybe let's go first like this. So you go to utility, and here you can also prepare some properties, your property sets. So this 3D model won't be only a 3D model, but also a BIM model. And you can add your own property sets here. And then when you go to create 3D model, you can select your property set table here. And then when you click OK, this 3D model is then created. Let's show it in shaded view. And now let's also add the terrain like this. So now you can see we have a 3D model of this dike, and we can also, if you go to utility here, you can also edit the properties on this. You can edit the properties on these elements. As you can see, you get automatically the name of the axis, the end and start station, the volume, and with the number. But as I said, you can also add your own properties. Then you can filter the elements using these properties, and you can also do the clash analysis or export the model to IFC. So basically you can, this is all the things you can do with AQUATERRA. And AQUATERRA works on AutoCAD and also on Civil 3D, but also on BricsCAD. We support HEC-RAS, but also MIKE by DHI, which is also software for hydraulic analysis. And here I have another example where the model was imported to MIKE Hydro. So this is on BricsCAD, the same example. This is in MIKE Hydro. You have the alignment and cross sections, and then you do the analysis and you get the results. And also you can view the results in MIKE Viewer, and you get them like this. So this is all from my side. I will pass it back over to Gregor, but if you have any questions on what we have covered, please feel free to ask.